Alright, so today I have a little bit more of the circuitry required to get this whole thing up and running. Basically what I have here at the current moment, this is my ROM chip, this is the CPU, this is the address multiplexer that interfaces with the dynamic RAM, and this is going to be the dynamic RAM array. So right now I currently only have one dynamic RAM array attached to the circuit itself. Or I should say dynamic RAM chip, not dynamic RAM array. But basically the way that it's going to work, from what I've seen as far as the data sheet is concerned, is that the data gets transmitted in through the RAM chip itself, through a buffer, and then the output basically goes into the input of the next RAM chip. So these are all pretty much exactly the same. The only difference that's going to happen with these is that instead of the dynamic RAM having the data come into it from the CPU or from the buffer, it's going to come in from the next chip. So it's going to go kind of like this is the way that I kind of have this structured right now. The capacitors that you're seeing here, they do say 104, but they are 0.1 microfarad capacitor, which is required for the dynamic RAM to function properly. It's basically a signal smoother, you could say. It's a decoupling capacitor for the circuit. The only thing is right now I actually just got to connect ground to the one that's actually hooked up to the CPU right now. I just noticed that. Luckily, before I turned it on, right? It's kind of hard to get in there, of course, because the wires are all in the way. But if I, you know what, let me see what this one, okay, that's a reset circuit, so let me just unplug that for a second and fix that capacitor and push the button back in the socket. Oh, the joys of working on a breadboard. Okay, just like that. And then this can go back into its place, just like that. Make sure that those aren't making contact. Alright. So we're going to turn this on. As you can see, the blue LED ring comes on. That tells me that there's no shorts, because if there was, then it wouldn't be coming on. And we're just basically going to connect this to here. Let me just see something. You can faintly make out that it's barely flickering there. You see that? It's flickering so fast that it doesn't really look like it's coming on very much, but it is. That's basically the data output. And what's happening is that the columns and rows are being address strobed, and then the address from this chip right here that comes in, it's basically reading the addresses from the 6809 CPU, and it's transferring its information over to the address multiplexer, which then knows how to handle the data and sends it directly to the RAM. So that's exactly what's happening here, is that it's sending the information to the RAM. If we connect this to one of the other address outputs, you'll see that we get a fully lit LED, and the reason being is because it's strobing at a very fast rate. This enormous crystal oscillator right there is actually a 1 megahertz crystal oscillator. Let me actually flip that around so you could kind of see the numbers here. But yeah, that's a 1 megahertz crystal oscillator, and then this one right here is 14.32, which is used for the address multiplexer. And we've got two 24 picofarad capacitors right here, a 1.5 microfarad, not microfarad, kilo ohm resistor that goes into the crystal oscillator straight from the oscillator output on the address multiplexer. And yeah, basically this takes in the information from the CPU, knows how to handle it, and sends it over to the RAM. The data goes through a buffer basically and gets translated into the RAM where it's stored. The output, to my understanding, is also eventually going to wind up going into the CPU. But for right now, I just have it kind of hooked up where the output is going to come into this LED as kind of a status indicator. Let's go ahead and start showing off. You notice that the LED is actually considerably dimmer right there. You'll also notice that the ROM chip itself currently is not in use. And the reason for that is because I just simply haven't hooked it up yet. Let's see if I could get this to focus real quick. Come on, focus on my hand. Focus on my hand. I don't think it likes my circuitry too much here. Come on. Well, the bottom line is, yeah, pretty much what it's essentially doing right now is it's just going through its usual routine. It might even have some stuff still stored in the CPU itself, as a matter of fact. I mean, I did write some code for it, but, you know, usually the code is supposed to be burnt onto the flash memory or EEPROM, basically. But the outputs do seem to have their own... Actually, you know what? Come to think of it, that's pretty stable across all of them. Let me reset that then. Let's see. Yeah, no, it's just going to do the same thing basically, because like I said, it doesn't have any programs running at the current moment. So what it's probably doing is it's running at a 50% duty cycle on all 16 address lines. Let me go over here to address line 15. Yeah, they're all pretty much the same across the board. And then of course, let me see, the RAM output. Yeah, the RAM output is actually off now. Let me make sure I got all of that stuff hooked up correctly, because I just, on a breadboard it's very easy to make mistakes. Very easy, for that matter. Very, very easy. Oh, there we go. It actually focused now. Okay, so let me run that again. Yeah, well, I'm going to hook up some more things to it, and we'll definitely get back to you. I'm testing to see the temperatures here. Let me see something. Yeah, they're not so warm. The voltage regulator is actually quite hot, not gonna lie. Like, burning hot, pretty much. Not in a bad way, but hot enough if you held your finger there for a little while, it would probably sting quite a bit. But anyway, hope you got something out of this video. Thanks for watching, and let me know what you think.